we've applied the mole concept to elements and compounds, the mole concept also works very well with molecular formulas. If you have H2O, you know that the subscript indicates the number of atoms that are contained in a molecule of that substance. So H2O would have 2 atoms of hydrogen combined with 1 atom of oxygen. If we don't see a subscript, then we assume that it's the number 1. CO2, 1 molecule of CO2 would have 1 atom of carbon, 2 atoms of oxygen. If we had a larger number of molecules, say 10, we'd have 10 atoms of carbon in 10 molecules of CO2. Notice that the number of atoms of carbon is the same as the number of molecules. Number of atoms of oxygen is twice as great because of that subscript 2. And what if we used a larger number still? Say 6 times 10 to the 23rd molecules of CO2. Well, we'd have that same number of atoms of carbon, and we'd have twice as many atoms of oxygen. And we chose that number, 6.02 times 10 to the 23rd, for a special reason, because that's the number of molecules in a mole. So if we had 1 mole of CO2, we could say that we've got that same number of atoms of C, that is 1 mole of C atoms, and twice as many oxygen atoms, 2 moles of oxygen atoms. And the useful part of the mole concept comes when we apply it using grams or mass. 1 mole of CO2, you know, is the molecular weight in grams. We could go to the periodic table of elements, find carbon, it's 12 in atomic weight. Oxygen is 16, there are 2 of those, so 16 and 12 comes up with 44, or 44.01 grams in 1 mole of CO2. If I had 1 mole of carbon then in that sample, again going to the periodic table and looking up the atomic weight of carbon, 12.01 grams of that is due to the carbon. The 2 moles of oxygen total to 32 grams of that sample. 1 mole of NH3 is 17.04 grams. Using the periodic table, nitrogen has an atomic weight of 14, hydrogen is 1, there are 3 of those, and the total is 17.04. Within that sample then, we've got 1 mole of nitrogen atoms, 14 grams, 3 moles of hydrogen atoms, or 3 grams. Finally, let's apply the concept to something where we don't have the coefficient, or the subscript 1, C2H4, 1 mole of C2H4. In that sample, we'd have 2 moles of carbon because of the subscript 2, and 4 moles of H. Now let's work 2 problems similar to those that you might encounter on a quiz or an exam. How many moles of hydrogen atoms are in 0.35 moles of C2H4? Whenever I see a problem involving moles or atoms, grams, molecules, I say to myself, factor unit method, because it's a very powerful way and an easy way of working problems like this. You remember in the factor unit method, you screen out all the words, look for the number that's given, 0.35, and tack on the unit that's associated with it. So here would be step 1 in the factor unit method. Step 2 is to find what we're after. Well, we'd like to know moles of H atoms. So I've put that clear over here on the right-hand side. We're going to be multiplying by some factor then that will convert moles of C2H4 into moles of H atoms. We need in the numerator the unit of the answer. So I know that moles of H are going to have to be there. In the denominator, I'd like to get rid of that unit that we've started with. So moles of C2H4 go there. And now let's find these numbers. And of course those numbers are what we had just a minute ago. In 1 mole of C2H4, we've got 4 moles of H because of that subscript 4. If we multiply, we come up with 1.4 moles of H atoms. The idea behind the factor unit method, of course, is that if the unit comes out right, then the number's going to come out right too. We've got two significant figures here. Our answer has two significant figures. These are exact numbers, and so they have an infinite number of significant figures. That means that our answer must have just two. Let's look at another problem. This might seem like a little harder problem, but with the factor unit method, it's not that bad. How many grams of carbon are in 0.60 moles of C2H4? So rather than panic, say to yourself, hey, factor unit method, screen out all the words, look for the number that's given, tack on the unit, look for the unit of the answer that you're after, place that unit up here in the numerator, place the unit of what we're given in the denominator, and you're almost there. You've got the problem set up so that the unit comes out right. And these numbers now we'll get by using the mole concept. If I had 1 mole of C2H4, we'll put a mole down here of C2H4. We know that we have 2 moles of carbon because of that subscript 2. And to find out what 2 moles of carbon weighs, we can go to the periodic table. Its atomic weight is 12.01. 2 moles would be 24.02. Putting those numbers in, our unit's going to come out right. We multiply and divide and get 14.412 grams of carbon. But then we want to make sure that we have the correct number of significant figures. Got 2 here, 4 here, infinite number with this number 1. 2 is the lowest number, so we'd round this to 2 significant figures, 14 grams of carbon.